Based on our pre-registration, we're closing in to a number where I think we can get started. And for those of you who've already signed in, thanks again. And this program is being recorded. I'll probably repeat myself a couple times because I'm not exactly sure how to start this, but Ryan Dardar from working with the Artemis Project and Orion, Lockheed Martin, and Patricia Moore are with us. Patricia's role in communication and outreach for Artemis. We'll go through that a little bit more formally, but we're also recording this so this can be part of the programming for the Neutrino Days, which for folks in our area know this is typically hosted in Leeds, South Dakota. And normally the Journey Museum and Learning Center would do outreach. We'd take a portable planetarium up there and show images of outer space and the stars. And obviously with the environment the way it is today, group gatherings and events like this are a little bit more problematic. And so the decision was made about 30 days ago to create a virtual event. And this is kind of our contribution to all of this. And so I got to thank Patricia and Ryan for helping us do this. But then this recording will be shared on journeymuseum.org on our website, in our Facebook offerings. And it'll also be a part of the Neutrino Days. And I know the team up at the Neutrino Days, Connie Walter and everyone, they are working hard to have lots of other collaborators presenting virtual learning experiences throughout the week. So be looking for that in early July. And I think you can find all of their content by just Googling Neutrino Days and finding the virtual format. For those of you who don't know, they're doing lots of deep science projects there, researching neutrinos, the building blocks of the universe, and Ryan's probably better at speaking of all of those things than myself. So I guess I've kind of started with here. Welcome everybody. I'm Troy Kilpatrick, the Journey Museum and Learning Center Executive Director. We appreciate you guys trying something new, learning in a new way, being online in our Zoom chat room today. I can't thank you guys enough. We have been making every effort during COVID-19 to continue to be a learning place for all ages. And so we're hoping today there's some kiddos online along with adults who are looking for inspiration and innovation as we find new ways for us to continue to learn here in our communities. And we're connected now in other ways like never before. Behind me is the Journey Museum and Learning Center. Today we don't have to have a gathering inside of our theater. We're all gathering virtually here today. And a recording, like I mentioned earlier, is being made so we can review this later. So after we're scratching our heads and going, I'm not exactly sure what Ryan said about that particular item, but I could research that and I could watch it again. It's available to us. And so it's robust learning opportunities. So thank everybody for that. And check out all of the other content that we have at journeymuseum.org. Coming Thursday will be our fourth attempt at this. I've got historian Donovan Sprague presenting on the Battle of Little Bighorn. It's on June 25th. It's the commemoration date of that battle. Donovan is going to bring the story from a Native American perspective. Most of the content that's out there is been written. It's actually the number one written about war conflict of all time is the Battle of Little Bighorn, or as it's known in the Native American communities, the Battle of Greasy Grass. And so Donovan Sprague, who's a descendant from Chief Hump and Crazy Horse, tells the story from a little bit of a different angle. And he has been presenting this program in our museum for the past 6 years. This year, he's going to do it through Zoom. And plus, there's new content. He's been part of an archaeological research and a dig. There's been new finds that have been discovered up at the battlefield itself. And so Donovan brings a different perspective, brings some new history to this. And we think it's an important date to kind of always mark here as a museum that remembers history all the way around, inclusively throughout all of our communities and through all of our community members. It's important to bring a couple different perspectives to these types of dialogues. And so I hope you can join us Thursday at 2 o'clock for Donovan Sprague, Battle of Little Bighorn and Greasy Grass. If not, again, that will be recorded and will be available through content there through our channels. So we're working hard to create even more opportunities for all of you out there today. So thank you again, everyone who's out there. We appreciate your time today being here live with us. We hope you're going to get an opportunity to ask some questions for Ryan throughout this conversation. But let me introduce Miss Patricia Moore first. She is with the NASA's Communications and Outreach for the Artemis Program. And Patricia, way back in the olden days when we were a museum that was open for business, reached out to me to coordinate to come and see us. And I said, well, here's a good time. Why don't you come see us around April? We'll have a brand new UniView system installed. And who knew what we were going to get, right? But Patricia stayed on schedule with us, kept in communication. And then I said, hey, well, what can we do to be creative? And so here we are today. So I'd like to introduce Patricia Moore and thank her for everything she's doing for NASA and keeping us connected. The Journey Museum and Learning Center is so fortunate to be a part of the NASA Educational Network. If you saw our email today, we've got NASA Kids curriculum. We're part of the South Dakota Space Consortium, and obviously science and space exploration is a big part of the story that we tell in creating new knowledge. So I'll turn the floor over to Miss Patricia Moore.
Well, good afternoon, everybody. Again, my name is Patricia Moore, and I work at Johnson Space Center, and I'm part of the Artemis Communication and Outreach team that shares NASA's story, returning humans to the moon. So today we're very fortunate to have an engineer working with Lockheed Martin, one of our industry partners, and the Orion program. And Ryan Dardar works with Lockheed Martin specifically on the Orion stress and analysis. So I'm going to turn it over to him, and he's going to talk to you and show you some slides. And then throughout his presentation, if you have any questions for him, please put them in the chat. I'm monitoring the chat, and then once he's finished, we'll do some exciting question and answer. So I'll turn it over to you, Ryan.
Hey, how's everyone doing today? I guess no one really can answer that question, but that's good. So folks asked me to come in and talk a little bit about the Orion vehicle and what it does. Maybe there'll be some links related to some videos that can also be added as a reference for folks to go out and take a look at. But a little bit about me. I work for Lockheed Martin, like they mentioned. Specifically, we have lots of, it takes a lot of effort and a lot of work in order to, get to space and get to, having a deep space solution that requires people from around the country to come together and design and test and analyze and make sure that, from a safety perspective, you're doing your very best to make sure that your products and your solutions that you're creating are indeed going to work like you expect them to work. I live in Louisiana. I've been working with Lockheed Martin since 2004, started on the external tank program before they retired the shuttles. You can see in the background here, that's also out on the Michoud Assembly Facility floor, which is 43 acres underneath one roof. That's where we build the Orion primary capsule structure there. And that's also where SLS is being built, which is the next generation rocket. Next slide. So a little bit about Orion. The capsule that you see in the middle, which is the crew module on the side, on the middle left, is what you see the piece parts behind me, I'm pointing, eventually become and make that crew module structure. Below that, and when you're in space, you need to have a service module. We call it the service module. It gives us our in-space propulsion system and allows us to get to the moon, get to Mars eventually, and then on top of us, which is to the right here, which is our launch abort system. Something that is really important with how we put humans on rockets is to make sure that they stay safe, and this abort system is there while underneath the largest sets of loads that the crew experiences. If something wasn't to go right, this launch abort system allows it to pull the crew and the crew module structure away from something that would take place with the rocket, something bad, of course, but bring them to safety and get them to safety. Parts of the launch abort system that you see here is you see the abort motor, which is the motor that creates the real big thrust in order to get you away from that emergency event. And then you end up with some jettison motor, and then the control motors, which allows it to pitch and eject. And maybe I'll have a slide on that. But we've been going through testing since 2010, and we just completed last summer the Launch Abort System 2 test, which was out at KSE, which was a real success. Next slide. So Orion's role in all of this is to make sure that we can transport our crew, our astronauts, the cargo that we need to our near-term goal is to look at the lunar orbit, get them to the lunar orbit, and then return people back. That Orion system, once it's around orbit, will then work with other systems like a lander or other spacecraft in order to go and land and do the lunar type explorations. But Orion is that capsule that gets you back and forth to Earth and then to the moon. What you see here in the pictures shown are, you see a gateway, what we call the gateway structure, is what's needed in order to go around the moon, and it stays as a base of operations. And Orion comes and docks with that gateway system, and then they climb into the gateway, and then they climb into the lander, and then they'll go and land onto the moon. And then when they're finished their tasks out of the moon on the lunar surface, they'll come back to that gateway location and then get back in Orion and then come home. What is unique for Orion, and we'll get to a little bit as to what's unique about Orion in a little bit, but what Orion allows you to do is to get back into the atmosphere and get back into the atmosphere safely because of its TPS systems, its thermal protection systems, and its heat shield. You're coming in at a very high rate of speed, and I'll show some of those numbers in a bit. But what that heat shield does and what Orion does is keeps the crew safe as they're re-entering. The re-entering part is the most extreme case of environments that it goes through. Next slide. So in order for us to do all of that, in order for us to have that mission, in order for us to complete that mission, we're contracted to go out and build Orion, but we also work with a number of other suppliers around the country. Like I mentioned a second ago, we are just a small piece of a country's worth of efforts that are going into it in order to go build all these parts. And this just gives you an indication that we're using resources and expertise across the entire country. Next slide. Specifically here in New Orleans, also in the background here, not shown, is we do a lot of the assembly of a lot of our composites. Now, you have metallic structures, you have metal, but then you have things where, I don't know how familiar folks are with composites, but a composite is multiple different materials that come together in order to take advantage of strength, in order to optimize weight, in order to lay up certain strength where it needs to be, and optimize and remove mass where it doesn't need to be. And what you see here is a large composite structure that's being assembled and fabricated out in the New Orleans area. Next slide. This shows one of the back sides of that, and just to give you a sense of that scale of how big it is compared to the workforce that's out there, and they become fairly big structures. What you see on the right hand side is also some equipment or some, it's the SLS rocket that is being manufactured here as well. Now that is much bigger than what you see on the left, and it's a sight to see in person. So the Orion capsule, so as the primary structure is built here in New Orleans, it's assembled, it's sent over to Florida, and it goes into its the remaining assembly operations where they put the thermal protection, they put the wiring, they put in all the components, and as it's finished, part of our testing and checkout is to go and have the completed spacecraft through a series of tests. And one of those tests that we do is out in Plumbrook, which is in the northeast U.S. And what the Plumbrook station does is we do acoustic testing. That acoustic testing is putting giant speakers around it and blasting it with sound to replicate the environments that it would see while the engine for the launch vehicle is running, and also environments that it would see in the case where we have a launch abort and the motors from the launch abort system were to fire and impart loads onto and sound, really loud sounds, onto the vehicle. Next slide. So what you see here is it being put into one of the chambers on the bottom left-hand side. And when these giant structures get shipped around, it's always neat to see. You wonder, okay, how do they package this stuff? It doesn't necessarily go in an Amazon type box, right? But in this sense, they wrap it with plastic in order to keep it protected from the different environments. And what you see in the middle here is it completely wrapped up and ready for shipment to ship it back across the country. And this is a picture of it either leaving or coming back to the Florida facility. So what you see in this picture, so once it's in that Florida facility, they do a lot of the component mounting and environmental systems and the wiring and the plumbing. But what we're taking advantage of from a technology perspective is augmented reality operations. It's a really impressive thing to see. The technicians who are installing parts, they wear these glasses that you see in the pictures here, and with a little bit of technology, probably a lot of technology in that sense, they understand where the vehicle is in space, and when they put the glasses over their heads, they can actually see the computer-aided parts, the CAD parts, and the designs in space. And they see it in front of them as if they're looking at it as it's real. And what you can do at that point is precisely place components where they need to be placed. They can do installation operations. They have everything in front of them before it's in front of them, so they know where it's going. They know how to go install it. It prevents errors. Make sure that it looks right. If you're doing anything in your garage, you take a step back and you say, well, that doesn't look right. And this allows them to look at it and see it beforehand. So it's a new generation of how things are assembled, how things are designed, and how things are communicated in a manufacturing sense. So as I mentioned, we go across the country in order to utilize resources and build the Orion capsule. It's also a worldwide effort. We utilize the European efforts, and they help develop the service module. And what you see here is the service module structure from the underside, and you see these giant red protection cages to protect motors that are underneath it. But it's a nation of nations kind of task that's going on. Next slide. And this is just showing some of our European partners as they, they're always happy to see things go out the door as well, just like we are when we, complete things. This is just an idea as to all the international contributions that we get, from the European side of our efforts, and just goes to show that it takes a lot of effort, and there's a lot of expertise out there, around the world, and we try to utilize those expertise wherever we absolutely can. So you saw a little bit of Artemis 1, you saw a little bit of Artemis 2, which is in at KSE and being assembled right now, and that'll have the first crew that'll fly on it. But what you see in these pictures are some of the beginning pieces of Artemis 3. Now, Artemis 3 isn't expected to fly until 2024, but what you see is the structure of the crew cabin for Orion that the astronauts will see out of as we send the first man and woman to the moon. I mean, this is, if you take a step back and you think about it, there will be a male and a female astronaut looking out of that cutout hole of the window section, and we are making that right now today. So with all of our other testing operations and making sure that everything stays safe and we keep the crew safe, how a very complicated system should be checked out is we created these integration test labs where all the equipment that is expected to be on Orion is installed and run through all the software and all the programming and is assembled and checked out in one of these labs. So everything communicates correctly, everything talks together, everything plays nice in that sense, and as a system, the system works. And then this is that test bed that is used in order to make sure that it all works and works together. So another part of our testing efforts is making sure that it's something called human in the loop testing. And as much as we engineers think that we know what astronauts need, and then we have an understanding and we understand what they want, having them go through efforts as we develop and build this thing from the ground level and make sure that they're in the loop has minimized a lot of risk and saved a lot of time and made design changes in order to best suit what they need in order to have what product and what equipment and what situation and how it should be laid out in order to make them be as effective as possible. And some of those operations are practicing at sea. At some point the crew splashes back down into the ocean, and how they do those at sea recoveries is important to how to operate the vehicle, how to deal with contingencies, how the crew is expected to get out, and how they tow it back to the ship, and as they're going through all those exercises, they take notes and they provide feedback, and we listen and we understand and we adjust. Same thing with hand controllers and having your data display equipment shown here, getting feedback from them and adjusting and making sure that it's laid out the way that best works for them is really important. What you see, that's fine. And what you see here and the rest of them are other examples of situations that we've done testing, we've kept them in the loop, and we've taken feedback and we've made changes and adjusted, and they understand what it takes in order to execute their job, which is the exploration piece of that. Next slide. So this is another picture. So this is out at Johnson Space Center out in Houston. This is the giant pool where they do all their water operations and crew training. I've seen this a handful of times when I've been out in JSC. It's a really neat sight to see. But here they show the crew getting out, climbing out of the hatch, and what equipment they're going to be having, and just to get them acclimated to the environment that they will see, because seeing it on paper, seeing it in computer, it's good, but experiencing it, that's where you learn the most. So as I was talking a little while ago, say a year and a half ago, we had our AA2 flight. I was actually thankful enough to be at that flight. This was out at KSC. It was in the July timeframe of last year, and what you had is you had a motor that represented the rocket, and you had the launch abort system on top of it, and the whole test was to make sure that the launch abort system was going to work as expected, and when they expected it to happen. And what you see is a progression from left to right is the launch abort system starting to fire. It pulls the crew away from the rocket, where something has gone wrong, or the environments have changed and the crew is no longer safe, and it needs to remove them from that launch vehicle. And as it gains and clears that launch vehicle, it goes through a series of maneuvers where it flips itself upside down and then fires motors in the opposite direction in order to separate itself from the crew module. And what you see, you see the separation, and then you see the crew module floating down. What you see in this picture here is out in Florida. This is where you had Artemis 1, you had Artemis 2 that was in the works, and then you had the EFT-1 flight that was flown in 2013, all together in the same building. And of course, when that happens, you can't help but not pass up a photo op. So this just goes to show you the number of folks that are out there working on a daily and nightly basis, a lot of times to make sure that it is prepared, it is safe, it is ready to go and not and perform as expected. So at the beginning of this, I talked a little bit about what does it take in order to come home safely, and what does Orion, being the deep space capsule, do. You have two different kind of boundary lines. You have low Earth operations, which is where like the International Space Station stays, and then the things that are orbit around the Earth. But then Orion, being deep space, and deep space includes lunar, in this sense is it has to be able to come home from lunar operations, and if you're in low Earth orbit, it takes 3 hours to come home, and it takes 3 days to come back from the moon. It takes months to come back from Mars. As you re-enter the atmosphere, your heat shield can get as hot as 5,200 degrees, which then of course creates plasma around the heat shield, and the heat shield helps dissipate some of that heat. Now, coming back from the lunar surface or deep space, you're coming in a lot faster because you're looking to get home. And in order to get home sooner, you got to come back faster. And so your speeds are your speeds are increased. And then, of course, orbiting around the Earth, you're 250 miles from the surface, and from the lunar surface, you're 10 times or 1,000 times farther than that. Any questions? I'm sure there's a lot.
For those of you on the call here, you can sign in. You can ask a question at the Q&A there, and Patricia and Ryan can kind of fill in. Ryan, to get the ball rolling, I've got a couple questions as I was sitting here, and I mean, it may be silly questions. I specialize in those, but how many different capsules are you guys Are you creating? Are you building it just at one at a time, or do you have multiples that are kind of being designed? Is that part of the process? Can you talk about that a little bit?
So we usually build one at a time. So we have the Artemis 1 mission that is going to fly on SLS fairly soon, I hope. Then you'll see the progression, right? Artemis 1 is the first launch, which has a capsule. Then you have Artemis 2, which is the next capsule. The Artemis 2 is, at KSC in production, and then, through, getting in the process of putting in all the components and building that. Now we're building the Artemis 3 pieces. That's about as far as we've gotten so far, but we're getting past the engineering side of the development of it, and we're getting more into a production phase, which is looking to go and start producing them at a rate in which there's a need.
Is there a projected, like, how frequent all of this then is as far as a flight schedule then, Ryan?
Patricia, I'll look to you to answer that one.
Sure.
I'd like to fly a couple of times a year if it was up to me.
So right now our timeline looks as though Artemis 1 that's the first integrated flight of Orion and SLS without people in 2021. And then from there we have Artemis 2, which would be a crewed flight just to orbit around the moon and come back. And that could be late 2022, maybe 2023. We don't have exact launch dates for anything just yet. And then 2024 is the goal to have the lunar surface operation, where we have a crew of astronauts going to the surface of the moon in 2024. So that's our goal, and we're working hard to make that happen. How's that?
That's pretty good.
So there's a question from our audience. And I'm going to add a question to it. So why don't you tell us a little bit about your background and how you came to work with Lockheed Martin in the Orion program, and then maybe some of the aspects of your job that you enjoy the most.
Perfect. So I'm born and raised in Louisiana. I'm Native American. I'm part of the United Homeland Nation, and grew up to a commercial fishing company, or commercial fishing, family. It's what I grew up doing. I grew up on the water and shrimping, and maybe there's some Forrest Gump references in the middle of all of that. But did I ever expect myself to be in this type of position? No. I knew I'd go to school. I knew I'd make good grades, and wanted to do engineering, and as I got out of engineering, I dumb luck fell into the role that I got hired on, and I started to learn about space, and I wasn't one of the types that I knew exactly space was going to be my thing, and that's the thing that I'm going to get into, and what I learned on the shrimp boat is how to work and how to work hard, and you put in what you get out of it, and the rest, starting on the external tank program and then moving over to the Orion program, and then getting myself into a more analytical type role where we have different branches of engineering. You have designers and you have designers who go and build things and look to make sure that they can be manufactured, and then you have folks that are in my type field, which are the analysis analytical folks that look to go and make sure that the designs that are being created will work the way you expect them to work, will take the loads and in environments that are going to be imparted onto them, and how you go and connect those dots, and how do you meet the requirements to ensure that we are keeping the crew safe, and that their environments are going to be what they expect them to be. And then in the middle of that, after we get through all the analysis piece of it, in Lockheed Martin versus NASA also has requirements to say, okay, prove it. So part of that prove it part of it is going through all the testing. And there's something called qualification testing, which you put it through the ultimate type loads that you would expect to the vehicle to see. And some of that is environments where you're blasting with sound. Some of that is environments where you're zapping it with electricity. Some of it's environments where you go put 65 elephants on top of it and have them jump up and down on it at night. And structurally show that as your capsule's being loaded, it can take those loads. And we did that just a couple of years ago with all of our structural test articles, which are an identical replica of what the vehicles that you see in these pictures. And just to make mention, you talked about how many vehicles we make. Part of that is not just Artemis 1, Artemis 2, and Artemis 3. Part of that is building test articles in order to go and do the testing that we need to go do. And of course, during the testing, it's really nice when you can just high five each other and say, all right, we got through, it took it, there's no findings, everything was fine. But sometimes you'll fail things, and it's important to fail in this type of stuff, and you want it to fail in the testing phase of it, because you learn more when you fail, and it's things that we've learned along the way, and maybe it's a life type lesson, but that's the reason why you test. Now a lot of our things worked out really well, and it's because we have a really good team that's out there and that's executing everything.
So are any of the components of your Artemis 1, 2, and 3 spacecrafts reusable? Are you going to be able to reuse any of it?
Yes, absolutely. So you got the capsule itself, which from a production perspective, we'll look to go and fly some of the capsules, and as we progress, we'll look to go and reuse components to start with, and then eventually the actual structure itself. So it's recycling in that sense, that you don't have to go and build a whole nother article or a whole nother vehicle, and you can take bits and pieces from it, and you can eventually get to reusing the entire spacecraft, besides the things that you end up having to change the heat shield, because when you come in, it gets all burned up and charred up. It does what it needs to do, which is keep the astronaut safe for that one time.
So you mentioned the heat shield and keeping the astronauts safe. Can you expand a little bit about that, and how do you keep from burning up? Those temperatures are incredibly high.
So, all right. So what you see here, I wish I had another graphic, but you see the primary structure piece of that's the metallic piece. What you don't see is if you go back to maybe this first slide where it had the entire vehicle stacked up.
Give me a second, I'll get there.
But what you have while you're bringing it up is What you see there in the crew module in the shiny looking thing, that's the thermal protection system. You know, they're not connected. It's very isolated, and it's connected in only very, you know, limited locations, and that allows the TPS, which is on the outside, and the heat shield that's on the outside, in order to get really hot, and you know, it insulates. It's kind of like taking something out of the oven, and you put the oven mitt on, and you can go grab it and you can take it off. But what it's designed to do is of course, if you grab anything hot with the oven mitt and you just hold on to it, right? And you know, eventually you're going to get surprised, because it's going to, you know, say, soak through, and it'll get warm. This system here is designed to keep it, and keep the astronauts, and keep, you know, effectively that hand inside of the mitt cool for the period of time that it needs in order to re-enter the atmosphere and splash down.
So can you talk a little bit about like how the heat shield kind of dissipates, and ablative, I think, is the right word, right?
Yes, that is right. So part of the heat shield is, yeah, it's not just a shell that bounces the heat and, you know, rejects the heat. It actually is a term called ablation, which it burns off, and the process of it burning off, it you know, dissipates the heat, and it keeps the rest of the structure from getting beyond a certain temperature. So you end up with a certain amount of ablation that's expected, and that's what keeps you from, you know, ever seeing the 5,000 degrees of temperature as you're re-entering, and you know, it keeps it at a known and steady temperature that you can then go design your structure to.
So we have a question about, and I'm happy to answer this one if you want to. They want to know how many women are involved in preparing for our missions to Artemis, maybe on your team, and then maybe I could talk a little bit about the astronauts that could potentially, the female astronauts that could potentially be going on that first Artemis 2 and Artemis 3 missions.
I'll let you cover the first part, but I'd like to answer after.
Okay, so what do you want to talk about, your engineering team, or do you want to talk about the astronauts?
Engineering team.
Okay, all right. So for astronauts, we just had a round of new astronauts selected within the last year, and there was an equal split. There was half and half, half male and half female. And so we'll definitely have a woman. We have a good representation of women in the astronaut corps. It's not half yet, but it's getting closer overall. And so some of the women, if you look them up, they're called the Turtles. The last round of astronaut selections, they named themselves the Turtles. You'll be super, yeah, they'll be super impressed with their backgrounds. It's like one of the women was selected when she was like 28 or 29. She's a PhD in scientist and been doing research in Antarctica. So across the board, the men and the women have super impressive backgrounds. So I'll let you talk about your team, the engineer team, Ryan.
Okay. So from an engineering perspective, yeah, we end up with a mix. We have women and we have males that work with us. There's probably, I'd say, in the office, right, in New Orleans, but you know, within our group we have, you know, it's probably 40% female. We don't have a very big group, and our efforts related to the analysis field is, I think in engineering altogether, you don't end up with a, you know, maybe a proportionate male versus female set of numbers, but we most definitely have 5 or 6 females that we work with, and you know, I'd say there's more females in the industry now than there were in 2004 when I started, and yeah, that's good. It's diversity. It's everyone brings their life experiences to the table, and everyone has a little bit of a, you know, different experience. So, and it's good.
Yeah. So we have a question about augmented reality. So in addition to AR, what other innovations have occurred as you're building and training astronauts for Orion, and anything new within the last year that would maybe pique everyone's interest and be exciting.
Well, I don't know about the astronaut training piece of that, but I know from a manufacturing piece. I mean, it's there's a real big industry push to make sure that we start to utilize the technologies that are out there, and I say old school versus new school, but use what's new that works well, and try to integrate that. And this augmented reality piece of it is a really neat new tool that's out there, and it's still being developed. It's still it's not, all the kinks aren't worked out from the external tank days where everything was, on Mylar type drawings, and people talked of slide rules and engineering type jokes like that, compared to 15 years later, talking about manufacturing plans and efforts that are all digital. And you put your glasses on that. I would have lost a lot of money betting on that 10 years ago, saying, well, yeah, that's where we'd be at this point in the industry.
Yeah, so for the astronaut training at Johnson Space Center, we have pretty impressive virtual reality labs that allow them to simulate their spacewalks. So of course we can train in the pool for spacewalks, but they also have a really impressive setup where they do virtual reality, and they're positioned and their body's positioned so that it feels as though they're moving differently than you would here on Earth, and they can kind of go through the motions of grabbing on to different things on the outside of the spacecraft, of the space station. And I know that there's impressive simulators for all of the different launch vehicles and spacecraft. So VR and augmented reality is the wave of the future for sure.
And you talked about, they talk about innovation, right? You can develop something, you can design something, and then you can go build, a mock-up of it, and go and see, and kind of feel and touch, and there's visual learners, and this allows that visual learner to not necessarily have that physical presence of a mock-up or demonstrating type vehicle, and they can put the glasses on and they get that, and you get that almost instantaneously once that's set up, and that shortens that iteration time in order to go and say, well, no, I didn't quite want that over here. Let's go move this and put that over there, and you get that instant feedback, and parts of that is just it's the simple things that you can get caught up with, is looking out a window, right? It's like, okay, you think, okay, I'm looking out of a window, but in order to get the feel, in order to get the environment and the height of the window and how you're looking out of it, you'd end up needing to go and build something in order to really have an understanding of, okay, well, maybe I'd like that window a little bit further down. And this allows you to get that instant feedback.
Yeah. So tell us a little bit about some of the maybe the big tests that you and your team have done. So I know you do a lot of structural loads. So is there any kind of fun story or anything unique about a surprising a surprising result to any of the tests that you and your team have conducted?
Surprising results. I don't know, from a testing perspective, you ever really like surprises? Have we been surprised before? Yes, well, we have been. It's always neat to see a team come together when there's some adversity in the middle of it all. And from a testing perspective, it was maybe 3 years ago when we went through all of our structural testing. I was a big part of that. I led that effort, and that was testing all the components that you see in the background here, all put together as the capsule itself, and putting it through all of its structural loads. So what loads the launch abort system would put onto it, the pressure loads on the inside, the side loads from the environments as it's being ejected and released, and taking into account the temperatures that it sees, and all the different environments, and it's trying to add up everything that as a whole and going to go represent that as the most simple test as you can possibly go represent, because it's all very complicated. I mean, you get all these different, say nickels and dimes that add up that represent some total environment, and you can't go replicate that on the ground. And part of our exercise and part of our task is to go and find a way that ensures that the environments that we are putting it through from a test experience is indeed representing the environments that the crew could see. And no, go ahead.
And I was going to ask about the crew. So, where does the crew train with you? Do they come out to Michoud and New Orleans? Do they do most of their training and integrating with you guys at JSC? So, where do you interact with the potential astronauts that might fly on Orion?
So I know that there's a set of mock-ups that are used for all their interactions out at JSC, and then we have Lockheed Martin folks, and we work hand in hand and in line effectively with our NASA counterparts to go and do some of that testing, and they report back. The neatest thing about the Orion program here is it's not, we're a partner in all of this with NASA, and we work hand in hand with them, and they help us where we struggle, and we help them when they're struggling, and they understand our tools. We give them our tools, and they give us their tools, and we find what best works. But it's not a case where we have to do everything, and we know that they can provide some expertise where we need it too.
Awesome.
And they do that a lot with the mock-ups.
Yeah, we have a really great industry team that works with NASA. So we showed you that picture earlier, that those are all of the places in the U.S. that are industry partners with Orion. But we've got industry partners with the Space Launch System rocket, with the habitats, with the landers, with the gateway. So Artemis is such a huge program, and NASA is working with companies all over the United States to make that happen. It's pretty cool. So we've got about 5 minutes or so left. So do you want to ask, I have another couple questions I can ask Troy, or do you want to pop in and ask a question before we get close to wrapping up?
You go ahead, Patricia.
Okay.
We're on about that timeline, so I think
okay,
we're
perfect.
on the same page there.
All right, perfect. So, so you talked a little bit about your background and how you kind of made your way to Lockheed Martin. So I know that there are students out there that are watching that maybe want to work at NASA or at Lockheed one day. So what kind of advice could you give to them to kind of take a similar path as you?
So I tell my kids this all the time. Hey, look, you get what you put into it, and if you want something, then you can be willing to work for it, and don't give up on your dreams. I mean, I kid you not, my dad can't read. Never can. So I was the first to go to college, first to graduate from college, first to do a lot of things, and that's no different than anybody else. Nobody else, you shouldn't. Don't make an excuse. If you want something, go and work for it, and go make good choices and make good grades is what I tell my kids. And it typically works out. But there's a lot of space stuff still coming. And we have the continued production of the Orion efforts. We have the SLS rockets. We have landers coming up. We have, the equipment that's needed to be on the surfaces. We have Mars in front of us. There is generations of work ahead of us, and this is, some people say, maybe it's too late to get into it. No, not at all. So yeah, keep trying, keep reaching out, keep learning.
And one of the great things that companies like Lockheed Martin does, as well as NASA, is their internships for college students. So a great way to get experience and to get people to know you. It's always easier to get a job if you have connections and you have relationships within a company, but NASA offers internships as well as Lockheed Martin and all of the industry partners. So if engineering is something you're interested in, or science, check out, you can Google NASA internships or Lockheed internships to check it out. And you don't have to have straight A's to be an intern with NASA or Lockheed. I know that they want people who are hardworking, that are good problem solvers, and are willing to learn. So that's definitely something to check out.
And I'm a product of that.
Are you? Did you do an internship there in the Louisiana area?
I did.
So what were some of your first projects that you worked on?
So I started on the external tank program. It was during the return to flight efforts after
For space shuttle. Yeah.
Yep. And we're getting to the process of getting, back into the air, and worked for a summer, and I still had my senior year in college ahead of me. I was going to LSU at the time, and the impressions and the experience that I had allowed them to reach out and make me an offer, and start lining up me starting at the point where I graduated the following year, and the rest is history.
Yeah, and internships are so great. So you may think that you're far away from NASA centers up in the Dakotas, but you're really not. There are 10 different NASA centers all around the United States, and NASA helps get you to the center. So, there's stipends and opportunities to help get that travel and get you where you need to be. And I'm sure that the industry partners like Lockheed have similar opportunities. So don't think that since you're not close to Houston or not close to Florida, that you can't be a part of space. There are partners in industry and NASA centers that are closer to you than you think. All right, Troy, I will turn it over to you for closing remarks. Here we go.
Well, so Patricia and Ryan, again, thank you so much for making yourselves available to us. And just to follow up for any students who are watching the program, to go check out the South Dakota Space Consortium site. There, we funded probably over 40 students in secondary universities throughout the state of South Dakota this past year. And I know we're always looking for innovative ideas, for opportunities, for grants, for groups that are doing educational efforts here. Just check us out on that website there. There's a lot of ways for students to get engaged. And as Patricia mentioned, it's just not all about a 4.0. It's about some of the other things that you bring to the table. We try to look at it that way. And be reflective of our community and provide opportunities for everyone. Again, I thank everybody on this broadcast for being here today as we explore new ways to continue to innovate and to educate, and not only our community, but around. Look for this recording to be available on journeymuseum.org. Check us out there for our other educational offerings and on Facebook Live, and check out Neutrino Days, those efforts up there in science. So I'm going to sign everybody off. Thank you guys for being here and being a part of helping us continue. Patricia, we're going to need to do a turtle program, Women Making History, in March. So I wrote all of that down. You and I will be staying connected. But somehow, some way, the journey does continue. And thank all of you for being a part of all of that. So goodbye for now. Thank you.
Goodbye, everybody. Thanks for having us. Bye-bye.